Today we're going to continue our voyage through Python functions. In the last video lecture, we looked at callback functions, which we noticed were a way to modify the behaviors of other functions. And the example that we used in particular was sort. Today, we're going to look at lambda functions, which are short, one-line, anonymous functions. And at first you might think, well, I don't really understand why that might be useful, but they are incredibly useful for callbacks as well as for some of the things we're going to talk about after lambda functions. So many languages have what they call anonymous functions. It's the ability to build a function that doesn't have a name, and that's why it's anonymous. Now in Python, normally we would write a function like this, right? So I have def, which is the defined keyword, and then I have a name for the function here. It's called full name. It takes a couple of parameters, first and last, and then I'm returning a concatenation. Now again, this is a very, very simple function. I don't want people to get confused about what the function is doing, but this is traditional Python syntax. What we can do with a lambda function is that we actually take away some parts of that. We get rid of the def, we get rid of the name, and we even get rid of those parentheses, and we get rid of the return. It seems like there's not very much left. But at the end of the day, that's about all we really need, actually, to define a function. And so in Python, we would write it like this. So again, you can see I just have my parameters first and last. I keep that colon, and then I return the value of first concatenated with a space, concatenated with the value of last. The keyword lambda there is the secret that tells Python that I am building a function. Lambda, I know, seems like a weird word to use there. It's actually a Greek letter, but rather than typing a Greek letter, we just spell it out like this. Now, these things are incredibly useful. They're very, very short, and they're very, very tiny by design. We can do several things with these new kind of lambda functions. Let me start with number 2 here. we really commonly use them in callback functions. So let's say that I'm sorting a list of names, but what I would like to sort is whatever the first name is concatenated with a space concatenated by the last name. So I can send a lambda function to the sort method as my key or my collation function. So this is a version of what we were doing in the last lecture when we send these so-called callback functions to places like sort to alter or change their behavior. Now, number 1 is that we can actually assign lambda functions to variable names, and we can call those variables just like we would call a function. So we can actually, if we wanted to, make a named function out of a lambda function. I call them lambdas. Well, here's a Greek letter lambda if you've never seen one before. But back in the 1930s, this guy Alonzo Church invented a style of mathematics which he called Lambda Calculus. And it used these things that might seem familiar to you in our study of Python, like anonymous functions, tuples, and chaining, and some other things. So Lambda Calculus was a really important area of research in the 1930s, and it has really influenced the philosophy of programming languages. So there are a lot of what we call functional programming languages today that are really based on this philosophy or based on this premise. Now, even if you haven't heard of Alonzo Church, you may have heard of his most famous student, who was Alan Turing. And we won't go down the history of computing here any more than that. But if you want to understand why these things are called lambda functions, it's Alonzo Church's fault. But one of the things you'll notice is that the designers of Python, it looks, right, they have spent some significant time studying Lambda Calculus, and the ideas of Lambda Calculus have influenced the way that we think about and write Python. All right, so let's take a look at that syntax a little bit more closely. Again, these are not big functions. They're really one-liners, and that's all they're designed to do. But the first thing we need is that keyword lambda, and that's the secret thing that tells Python what follows is actually a function. If we leave off the lambda keyword, Python won't know that any of these things are meant to be the definition of a function, and so we're going to get some weird errors as they show up. So the first thing that I list are the parameters. The function can take any number of parameters. Here it just happens to be 2, but it could be 1 or it could be 9. It doesn't really matter. And I don't really care, Python doesn't care, what these are. First and last here are designed to be like scalar strings, right? But it could be arrays or lists, I should say. It could be dictionaries, could be objects, other kinds of things. It doesn't really matter. And then after the parameter list, we have a colon. That is a hangover, a residue from the way that we defined functions before. And you know, Python loves those colons. So the colon separates a thing from its definition, right? A loop from its body, a function from its body, an if from its conditional else's, right? So Python loves these colons, and so the colon is still here. It separates the first part of the function definition or the parameters from the body. And then this is what I would return to the caller. I don't need a return statement because the lambda function just assumes that whatever I'm going to calculate there in that one operation is the thing to be returned. So again, these are not going to be giant functions. They're not going to be 20 or 30 or 50 steps in a lambda function. These are all really tiny, really simple things. So I know I don't always like to read a slide, but I'm going to read this one. Like, why even use a lambda function? And this is Mark Lutz who's writing Learning Python. I mean, he says, your def functions may be arbitrarily far away in your file, right? And they could even be in a different module. They could be in a different file entirely. So the code proximity that lambdas give you is especially useful for functions that will only be used in a single context. And moreover, def forces you to make up names for your functions, and that might clash with something else, right? So think of lambdas as a way to write an inline temporary function definition, especially right when that function definition doesn't get used anywhere else in your program. Now, the thing that seems limiting about it, and he calls attention to this here, is that the lambdas have to be a single expression, right? We can't put a series of 12 statements into a lambda function. There's only really one thing back there. And so he says that seems to place some severe limits on how much logic you can pack into your lambda. But if you know what you're doing, you can code most statements in Python as, and he calls expression-based equivalents, right? These are really, really short kinds of things. So this is why we actually want to spend some time learning things like filter and map, and maybe some other things that we're not necessarily covering, but that are also part of this general philosophy. Things like reduce and even zip, which we might get to because zip is really convenient actually, so we might want to come back to that one a little bit. Now, even though that seems like it would be a really harsh limitation, it kind of isn't sometimes. And in fact, Python lets us cheat a little bit on some kind of complicated constructions. We'll see this if else in just a second, but we've already done this in the past. We've substituted comprehensions for loops, and so there are other ways that we can be really clever inside a lambda function. So let's take a look at this. Here's a little lambda function that accepts one input parameter called money, and I'm returning the string red if the value in money happens to be less than 0, else return the string green. Maybe I'm doing some sort of data visualization or color coding a spreadsheet or something like that. Like, are my finances in the red or not? Right? That's it. Now, if I'm going to write that the long way, that's what this looks like, right? If money is less than 0, return red, else green. But I can do that in one line in Python if I want to. So Python allows me this kind of interesting syntax on an if-else statement. Now, what's interesting is I can, in fact, write that form of if-else anywhere in Python. I don't need to be inside a Lambda function. I can write it anywhere. In practice, however, people don't really do it very often. You'll see it occasionally, but not very much. And for those of you who've come from a different language, and you like the ternary operator in that language, Python doesn't have that. I'm one who likes the ternary operator, so I find that's a little sad. But anyway, this is as close as we can get to that. But this is an alternate if-else syntax that's acceptable everywhere in Python, but is very handy, obviously, inside a Lambda function. Well, let's look at this one. Here I'm accepting scores, which probably, I could verify with the rest of the code, is probably a list of some kind. And so what I'm doing is I'm just iterating through all of those scores. I am adding 5 bonus points to those test scores, giving everybody a little bit of extra credit, and then I'm returning that new list. So this is where I can iterate or loop through some data, modify it, and then send it back. If I'm going to do that the long way in Python, it probably looks something like this, where I create a new scores list that is empty. I go through all of the existing scores and I append a value of whatever that thing is plus 5 extra points, and then I return the new one instead. So I'm going from 4 lines down to 1 just by using a comprehension. So changing the loop into a comprehension lets me put that inside something really tiny like a Lambda function. Now in the next video, what we're going to see is that this is actually a mapping. So I can apply a Lambda function to the list called scores. And we'll see that in the next video. Here's another one, a little more complicated maybe. So here's what I'm doing. I'm looking through a dictionary of students. How do I know it's a dictionary? Well, I'm looking in the drawer called score. And because I'm not looking in a numerically indexed drawer, but a string indexed drawer, my guess is that students is probably a dictionary. But again, here's a comprehension. I am returning a list of A students if their score happens to be greater than or equal to 90. And so what I'm doing in effect is filtering out the students who have gotten an A from the students who are not getting an A, right? Now in Python long version, it might look like this. I might have A students as an empty list, and I'm iterating through students and checking to see if that score is greater than 90, and then I append, and then I return that. So here, I've gone from basically 5 lines, I guess, and an if statement. I put all of that into a comprehension, and the shortness, the conciseness of the comprehension means that I can stick that now into a Lambda function. In about 2 videos, we'll notice that this is actually a filter operation. So I can do the same thing by writing a little Lambda function and applying that Lambda function to a dictionary called students. And that's called a filtering operation. We'll see that in about 2 videos. Well, here in the interactive shell, let's just do a little bit of play with a Lambda function. The Lambda functions will become more useful in the next couple of videos because as an anonymous function, we probably don't even want to save it anywhere, and so we just want to use it temporarily. So using a Lambda function by itself temporarily doesn't really work because we want to save it into a variable. But let's see what we can do here. So I'm just going to collect a list of words here, and we already know that I can sort that. I can't spell sort. We know that we can sort that, right? So it would come up first. Blob, and then idea, and then red. So anyway, but let's send a different key. And here's what I'm going to do. I'm not going to put a space in there. You can put a space in if you want. I'm going to send a Lambda function. Now, I'm just going to take W as my input parameter. W kind of stands for word, maybe. But because the Lambda functions are always so short, I usually don't want to write any long variable names in here. Now what I'm going to do is I would like sort to sort it not on the very first letter of the word, but let's sort it on the last letter of the word. And so we know how to do that. We know how to slice a string. If I take the -1th element, that is the very last element of that string. So I'm sorting it not based on the 0th letter, but on the -1th letter, if that makes any sense. And now you can see how it gets sorted. So idea, the last letter is an A, blob's last letter is a B, zinc is a C, red is a D, the is an E. So this is one of the ways I can use a lambda function, again, as a callback to the sort method so that I can change the behavior of how things sort. Let's do another one. This one is a little bit more complex in its data structure, but this is the kind of thing you'll see lambda function used for all the time. So I'm just going to paste this in. You'll notice this is a list of 4 elements. Each element is a tuple. The 0th element of the tuple is a name, and the 1th element of the tuple is a test score. And you'll see that everybody has a different test score here. And let's assume that I want to sort this list. Now, every list has a sort method, right? However, because these are composite kinds of data structures, what I would like to do is I'd like to sort it based on the 1th element of the tuple. That is to say, I want to sort it based on the test score. So what I do is I send a new lambda function to the key. I'm just going to call it T for tuple. But what I would like sort to do is to look at every tuple but sort on the 1th element rather than on the 0th element. So for every pair that gets sent to the lambda function will return the 1th element, and that will be used by sort to sort this whole list. So if I ask you what scores are, now you'll see that William is at the beginning because he's the worst. We always need that. Hamnet, and then Judith, and then Anne. So I can sort a more complex data structure by sending a lambda function to the key. All right, one last, and then I'll give you a couple of things you can work on your own if you'd like. This one isn't as great because I'm going to put a lambda function into a variable, but that's okay. We'll see how to do that. So here's a list of names. Obviously, it's the Shakespeare family. And what I'm going to do is create a new variable here just called add last. But what I'm going to put into that variable is a lambda function, and I'm going to accept a name, which I'm just going to say is n right here. And what I'm going to return is n plus Shakespeare. This is nothing different than what we have. We've never seen anything like this before. No, I'm just kidding. So that's in the new variable called add last. And so what I can do is I can say add last, and I can actually send it some string, whatever I want to, and you'll see I get Bob Shakespeare back. So I'm taking that lambda function and just putting it into a variable. Now, is this a shortcut or any better than writing it with a def? In this case, it's not. This is just another way for us to play with lambdas a little bit. But what I can do is I can say, for name in names, and then I can say print, add last of whatever name happens to be, and I get all my names there. So again, this isn't really a substitute. This is no better than writing that function as a def. However, you can see that creating a lambda function, I can put it into any other kind of variable if I want to. Well, if you'd like to practice with some of these lambdas, here are a couple of ideas that you can do. A minor variation on what we were working on earlier, write a lambda function that accepts a first name and a last name, but return it in that kind of last comma first pattern, right? So just concatenate the strings slightly differently. In order to test that, especially if you're working in the interactive shell, you might want to put that lambda function into a variable. Again, that's not really different than writing a function as def, but it'll give you some practice with the lambdas. And then do it again, but modify that lambda function so that what you're accepting is a 2-element list as input parameters. And then use element 0 as the first name, but element 1 as the last name. And then modifying a little bit what we did here just a few minutes ago, write a lambda callback function to sort the following list according to that last comma first pattern, right? So here is a list of people, 4 elements. Every element is a tuple. So we want to extract the 1th element out of the tuple as the last name and the 0th element out of the tuple as the first name. And we want to sort that list of people according to the last comma space first pattern. And then if you'd like, go back and revisit that lambda function that we wrote that sorts a list of tuples by test scores. And just for practice, revise that lambda function to sort by the person's name instead of by their test score. And then do it again, but just reverse the order. So this will give you some indication about how we can work with lambda functions, and that's good practice as we go forward into the next couple of videos.